So, good afternoon, everyone. My name is Ken Pasakyan. I'm going to demonstrate first the hands-on activity 3, and that's on task 1 first. So, task 1 is experiment on conventional logic gates shown below and create a truth table of all possible inputs. In the same simulation, side by side with the conventional gates, use the equivalent gate and compare their output and the same with the same input used logically for creating this simulation. Here we have installed logically and first. So for the task 1 here, conventional gates, that's OR and NOT to be compared to an OR gate. So let's start. So let's first start with the so this is a NOT gate. This is a NOT gate. Then this is an OR gate. As you can see, it's OR gate, and we have light bulbs here. This is a buffer for the conventional gates. So first, let me show you the table. The table for NOT is the input input A 0. It's the output is gonna be 1. In input A 1, it's going to be output 0. So let's demonstrate ORT. I mean not gate first. So this is not gate. As you can see, it's input 0. That's off. It's off, and the output is on. Now let's put 1. As you can see, it's on, and the output is 0. Let's now combine both gates. So first is the NOR gate. Let's see the gate of NOR gate. This is NOR gate. Input for A and B 0 0. The output is 1. For A 1, B 0. The output is 0. For input A 0. For B 1. The output is 0. For input A 1 and input B 1, the output is 0. So here it is. Connect. As you can see, output is 0 0, and output of the output is 1. So let's compare the two, a combination of OR gate and NOT gate. I mean NOT gate. So let's connect all of them. Here, a combination of OR gate and NOT gate is the same as is the same as the same output of NOR gate. As you can see, the inputs are 0 0 here, 0. It's not lightened. The cable is not lightened, and the output is 1, the same. So second is 1 0. So let's put input A on. Let's input there. As you can see, it also has the same result. The combination and the NOR gate is having the same result. So for the next one, it's going to be input 0 and input A 0 and input B 1. So let's start. It's 0 this first, input A, then input B. As you can see, NOR gate is also, the output is 0, and the combination of NOR gate and NOT gate is also 0. So for the next one, it's The last one is all inputs are 1, then the output should be 0. So let's try it. Let's put input A 1 1, and the combination of OR and NOT gate is also 0. The, the For the NOR gate 1 1, the output is 0. As you can see, it has the same truth table. The combination of OR gate and NOT gate has the same truth table as NOR gate. That's for OR gate and NOR gate. Now for the second combination is the AND gate and NOT gate. Comparing it to NOT gate here, NOT gate, this is AND gate, and NOT gate, this is the subwoofer, and this is NOT gate. So now let's see the table first for AND gate. For NOT gate, I mean, it's going to be input 1, input A 0, input B is 0, output is going to be 1. For input A 1, for B 0, output 1. For input A it's going to be 0, input B is going to be 1, and the output is 1. For input A it's going to be 1, and input B it's going to be 1, it's going to be 0. So let's try it out. Oh, and this is for the AND gate. Input A 0, input B 0, output 0. For input A 1, input B 0, output 0. For input A 0, input B 1, output 0. For input A 1, for input B 1, and output 1. So let's first compare the combination of and NOT gate to NOT gate. So let's see. Let's connect all of them. So as you can see, the first one is out for the first input is 0 0, and also for the NOT gate is 0 0. As you can see, the output is going to be 1. It's on. So for the next one, out input is going to be 1 0. I mean input is 1 0. So let's also for the combine 1 1. As you can see, the input of combination of AND gate in NOT gate is output is 1, and the output for NOT gate is also 1. So now for the next one, it's going to be uh, 0 1 1. So let's start here. 0 1 1. As you can see, the combination is the same as NOT gate. The output is still 1. Now for the last one, input is 1 1 0. So let's see here. Let's put output. As you can see, the combination and NOT gate is the same as the same output. Here you can see it in the lines, in the wires. There's nothing going through, and that's for the combination. That's for the combination of AND gate and NOT gate, and the comparison for NOT gate. So, good evening, everyone. I'm here to present the universal gate. This is using the 774 HC02, or the NOR gate, the universal gate. So let's first go to the truth table. The truth table of NOR gate is input A, input B 00, output 1. For input A, B second, input A 1, input B 0, output 0. For input A, B, for input A 0, input B 1, 0, output 0. For the next one, input A 1, input B 1, output 0. So this is the truth table of NOR gate. So let's demonstrate it on Tinkercad. So this is gonna be input A, this is gonna be input B. So let's start simulation. As you can see, the inputs are on 0, 0, and lead is on. So now let's put input A on 1. Input A is on 1, and the lead, the output is 0. The lead is not on. Now let's go for the third one. Input The input B is 1. So let's turn off first. And input B, uh, let's put 1 on input B. As you can see, input B, uh, input B is 1, and the output is 0. So for the last one, it's going to be AB. The inputs A and B is 1, 1. So let's on input A here, and the lead is still off. So that's for the NOR gate using a universal gate. This is NOR gate, universal gate. So as you can see, it represent the the truth table properly, and that's for the NOR gate. So for the learning experience that this activity have given me, it's more understandable how to use the gate in a circuit, and how to really utilize it. And not only that, it also given me more knowledge about the gate, how it can be universal, or using the basic gate to create a universal gate. Uh, that's all the experience that I learned. That's all. Thank you.